opportunity, but I'm just going to go ahead and start.
You get camera shy.
Yeah, I know. It's
It's all
okay. It
right.
happens. It happens. Yeah. All right. So we have a warm-up where we're just finding convergence or the sums of the convergence series. So the first one is a nice, straightforward geometric. Just have a regular a over 1 minus r, and you end up with 25 sevenths. That should have been just a very straightforward one. The next one, you had to do what first? And what did you have to do first this one?
You had to change it to 0.
Yes. You have to change that n to a 0. And what's the first thing you do in order to do that?
You have to change it so one's in front.
Okay.
First one's in front.
You plug in the 3, right? Yeah. The first thing you do is plug in the 3 and evaluate it, and that becomes your new coefficient here, right? Okay. So you do that, you end up with negative 27/30 seconds. And when you evaluate, you end up with negative 27/8. All right. Any questions on that one? This one was tricky. So, do you want to do this next, or want to skip it and do the easy ones?
You can do it.
Okay. All right, good. So, let's do this one next. There's 2 gotchas with this one. The first gotcha is that the n starts with 1, not 0. But the second gotcha is that it's raised to the n plus 2 power. In order for the summation formula to work, it has to just be raised to the n. So the first thing I do is I convert this to the nth power. There's, yes?
Oh, wait, well, I thought you were going to ask if anyone was
Okay, tell me.
Nice.
Yes, Paul.
I don't know if this is right, but couldn't you just multiply, like, that's technically negative 2/3 to the n times negative 2/3 squared.
Yeah.
Yeah, okay.
So then, like, your term would be negative something.
Yeah.
Yeah.
Yeah, so you have a 4, you're pulling a 4/9 out front,
Yeah.
essentially, right?
Yeah.
That works beautifully. The way that I do it, and but what your way is absolutely fine. The way that I do it is just plug in a 1 and think, all right, so if normally my first term here, my first exponent would be 3, right? So if this was just an n, I would want to start with a 3. So that's the way that I do it, but what you're saying is fine too. So if this was because what you would do then is you'd have a different coefficient with a 1 here, and then you just convert that to 0. You'll get the same answer either way. So if you want to do it this way, just think when I subtract from my exponent, I'm adding to my lower limit, right? So if I have, because if I plug in a 1, I get 3. If I plug in a 3, I get 3. So it works. Now though, I've got a sum starting from 3, so I got to convert to a sum starting from 0. So I find my new leading coefficient, which is negative 8/45, which is what you would have gotten if you had done it your way and then converted down to 0. Oh, yes, sir.
So like if it was n equals 1, and then if it was to the power of n minus 2, then it would be like a negative n, so can you
You'd have an n negative
You
1.
can do that?
Yeah, and then you'd have to convert
Okay.
back to 0. But yeah, you could do that.
Okay.
You still, no matter what you get down here, you're going to have to convert it to
Okay.
start with 0. Yes.
So, wouldn't that just, because all I did is I just did the same way, I converted the n to 0, and then just did it the same way as if it were just n instead of n plus 2,
Okay.
and it worked the exact same, because if you think about like in your method, it'll be pretty much the exact same thing, because I'm just taking negative 2/3.
And it's still just negative 2/3.
Yeah, and I ended up getting negative 8/75.
Huh.
Wait, if you just didn't do it.
Ooh.
I just didn't
Yeah, I just didn't do the n
You know,
plus 2 thing.
I gotta think about that. If you even need it to the end, I just automatically made it to the end.
So we did
I don't know. Intriguing. Okay, so I will check and see if it needs.
Isn't that like,
I will check on that and see. All right. So for this next series, can anyone tell me? We all know what the first term is, right? 5/2. Does anyone know what R is? Okay, good. All right, fantastic. Yes, R is negative 3/7. All right. So just write it. This was actually a very simple one. There's your first term. There's your R to the end. Ooh, the last one. Is it geometric?
No.
So how do you find the sum? It's telescoping, right? So what do we have to use to rewrite the sum? Partial fractions. So math stuff. So we get 1 over n minus 1 minus 1 over n, and you can go ahead and start from 3. It's fine, right? These don't have to start at 0. So you just start with 3 and you start plugging in, you get a half minus a third, plus a third minus a fourth, and so forth. And all your interior pairs cancel, and you're just left with a half minus 0, which is a half. So there you go. Any questions on any of these? Everyone feels somewhat okay with geometric series and telescoping? Good, because we're learning new stuff today. The integral test and the p-test for convergence. Integral test and p-test. Yep. At the end of this lesson, you will be able to use the integral test to determine convergence and use the p-test to determine convergence.
No, during this relevance is pretty low.
By the way, it's technically, what does your sheet say? I don't think it's called like the p-series test. Yeah, the p-series test for convergence. I never call it the p-series test. I always call it the p-test. So just get used to that, right? Okay. So, all right.
Oh, you took chemistry?
But we're gonna start with the integral test. I don't mind saying this for the world to see. I am not a big fan of the integral test. I know that teachers are not supposed to have negative opinions about what they're teaching because then that influences your opinion, and if you like the integral test, I don't want you to feel bad about liking the integral test, right? But it is not my favorite test. I have other tests I prefer, right? So, yes. I do. You don't get to use it on anything, but you can have it as a reference, like while you're doing your practice. Did you not get one?
No, oh, I also need to use this. I need to use this.
Oh, yeah. Did you?
Oh, I will get you all of those things. Okay. So, here's what the integral test says. The integral test says, hey, suppose we take the rule of the series and rewrite it kind of as a function. So, like if your a sub n is, n squared over 5, then you would have f of x equals x squared over 5, right? So it's just kind of taking the series rule and writing it as a function, like with function notation. If you were to look then at that function, and if for all n greater than or equal to 1, the function was positive, continuous, and decreasing, then, if you find the integral of the function and the integral converges, that means the series converges. If the integral diverges, that means the series diverges. All right? There's a couple little things to note about this before we start in with problems. You don't have to prove f of x is positive, continuous, and decreasing. You just have to check that it's positive, continuous, and decreasing. So if you can look at a function and just kind of in your head think this is always going to be positive, that's fine, right? You don't have to, there's not a formal way to prove. Again, same thing with decreasing. If you can kind of mentally plug in a few values of n and figure out that they're always going to go down, that's fine. You don't have to sit there and do a first derivative and make a sine line and all that kind of stuff to prove decreasing. You can just kind of think about it. It's fine. Okay? All right. But it does have to be positive, continuous, and decreasing in order for this to apply. One other little thing I found out. If your series, if the sum starts with like n equals 5, then the integral would be from 5 to infinity, and then this would only have to be true for the x is bigger than 5, right? So it's really just whatever your lower limit is for a series, just know that it's, it's not going to be negative. Okay, so here is our first example. So what we're going to do is take a moment and see if we can figure out the convergence or divergence of this sum. So this is 1 over n squared plus 1. Now let's think about 1 over n squared plus 1. Will 1 over n squared plus 1 ever be negative?
No.
No, always positive. Check, right? Right, so, positive, because when you touch it, it changes. What? You just now learning that?
It's not positive.
Oh, yeah. No, she's just fucking high.
Okay, we're only dealing with real numbers.
It's not
Okay,
continuous.
we're gonna let's get past the whole imaginary thing, alright? So, only real numbers.
But isn't I a factor?
No, they're getting real, just going through.
We're only dealing with real numbers. Set of real numbers. Okay, so next thing we have to check is if the function is continuous. When you're checking to see if it's continuous, you're really checking to think to yourself, is there any value of x in the integral from 1 to infinity that I could plug in and make this discontinuous? Make us either divide by 0 or have a negative under a root or something like that. So, is this ever discontinuous? No, this is always continuous. So, f is continuous. Check. The last thing we have to check is it decreasing? So we plug some values in for n. If n is 1, we have a half. If n is 2, we have a fifth. If n is 3, we have a tenth. So we have a half, a fifth, a tenth, 1/17, 1/26, 1/37, right? I think, yeah. So anyway, what do you think? Is it ever going to go back up or is it always going to be going down?
No.
Always be decreasing. So f is decreasing. Check, 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 check. Once you have check, 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 that means yes, integral test applies. So if the integral test applies, your next step now is to do what?
Integrate.
Find the integral. A little gotcha on these integrals. It's the integral from 1 to infinity.
Improper integral.
It's an improper integral, which means you have to do the limit as b approaches infinity of the integral from 1 to b, right? And then do your antiderivative and then plug in b and then find the limit as b approaches infinity.
Wait, that's
Okay,
so
so
specific.
take a minute, do this.
That's so specific. Like, has to be positive.
Oh,
Yeah.
Plus Pacific.
Alright, get to work with this.
How do you figure out the arctan of infinity? Because I just kind of memorized.
Is negative pi
The
s.
arctan of infinity is the
Negative pi s.
angle where the tangent approaches infinity.
What it-
Sausage.
Might be pi s.
I got it.
Why is
Dude,
it?
it could be negative pi s too. Like,
Think of tan,
Yeah.
right?
Oh, okay, yeah, I got you, I got you.
Yeah.
is it not?
Oh, I was just thinking of a triangle.
True, true. Arctan of 1, arctan of 1.
The arctan of infinity
Is pi s.
Use x's. Yeah, just write it with x's. Alright, you should. Guys, you should write this with x's because you're doing the integral using function notation, not series notation.
I have, that's what I wrote. So I'm kidding, it's my fault.
Pi 4.
Yeah, I know, I can't.
Hopefully you can just recognize the antiderivative. Shouldn't take any work.
Arctan.
No, I can't.
Other cold on my own too.
Yeah.
Nah, man.
Brian did.
Yep. Brian did, game 27.
MIT.
Nice, nice. You're the real MIT.
Are you here to source your MIT?
Oh my god. You're the real MIT, bro.
Oh, stop. Tomorrow I'll be here. You have to slow down maybe.
Some kid, I want to say, third hour.
Did you figure it out?
I don't know.
Look it up. Popular.
Wait, what? What happened?
Okay.
Look
Make
it
sure
up.
you're writing.
I'll be there for the finals.
Like, he's
So
walking.
you should totally hit that link.
Well, you can't go on Friday.
Alright,
We have our own.
so,
Darn.
I don't know, but you
let's
did
take
it.
a look. Okay, there's a typo on my answer where I started with an n by x instead of an x. So please forgive me. Yeah, okay, so anyway, quiet please. So we have, this is our integral setup, which is equal to this this is an arctangent, right? So you have the limit as b approaches infinity of arctan b minus arctan 1. What is the arctan of infinity, Shreyas?
Pi over 2.
It is pi over 2. Can you explain why?
If you look at the tan graph, you see that it approaches infinity at pi over 2, and because it's an arc sine, you only do like that range.
Right, it's an arc, yeah. It's the same domain as arc sine,
Yeah.
right? Pi, negative pi halves to pi halves. Yeah, so that's the one you pick. Beautiful. So you get pi halves minus pi fourths, so you get pi fourths. Perfect. Now, that because the integral converges, that means therefore that the sum also converges. Now, the question of the day that I did not know the answer to until lunch today is, does the series converge to the same value as the integral?
Yeah.
No, because one is the added y values, the other is the area.
Okay, yeah, I can see that. Yeah, because your series, you're only adding the values at 1, 2, 3, 4, and for the integral, you're adding all the values, right, together. The sum from the integral will never be the same as the sum from the series. And Mr. Thomas suggested that I show you guys something, but I haven't actually tried it, and I'm worried about trying it on film.
We should.
You can
Do it.
I'm not gonna edit.
Do it.
No, I'm gonna try. No,
Don't be
I'm not afraid. Okay, so I'm gonna use Wolfram Alpha
Dr. Jackson yesterday.
for input efforts. So, if we want, how do I do like sum of series? Can I just type,
There's
What is
sum.
Oh, look at that.
Hey. What kind of socks?
Wait, I don't think you type the other.
Yeah, don't type.
Don't
I
type
don't think, wait, you can get rid of it if you want, I don't think it's gonna matter though, because the whole point of Wolfram Alpha is that it, like,
You can type in basically whatever you want and you'll come up.
Yeah, it'll find something.
It's a supercomputer
It's so
basically.
intuitive, it just knows what you think. You just look at it.
quiet
No,
please.
it's just like the.
It's the hyperbolic cotangent.
Cough.
So, yeah, so
Yeah, what is
COTH is the hyperbolic cotangent function. So you have pi hyperbolic cotan pi minus 1 times half. And here's the decimal approximation. You can get more digits.
Why would you?
Another one, there's more too much.
Another one.
All right, so anyway, someone do me a favor and do pi halves and tell me what you get.
It's like 1.05 or 1.6.
Here, I'll do it.
1.5
since no one's
something.
gonna cuss it.
1.55.
Dylan, what are you doing?
1.5507.
So pi halves is approximately 1.570796, right?
I just
So
changed the
not
power
quite
seven.
the same. This is really something. That's kind of a neat little program. Wow.
You did our
Okay, so not the
Have
same.
you ever used Wolfram? I used it for my calc homework in one of the chapters, and I got really confused, and then just type in whatever the question said, and it would like come up.
It can be really, it's a slippery slope. Like, you can reach a point very quickly where it just makes no sense what it says whatsoever.
Okay.
It told
Okay.
me way more information.
So I want you to take a minute in your partners or your groups or whatever and use the integral test to determine convergence or divergence for each series.
Oh yeah.
It gives you like.
Just because it's an integral test for a series doesn't mean the integral will be easy, right?
See.
So, for example, number 1 is a simple use of, but number 2 requires what? Don't ruin it. Don't ruin it? I won't spoiler alert. Okay, I won't tell you. You figure it out.
It's the VDPU thing.
Yeah, the VDU thing,
I
yeah.
can't remember what it's called.
Integration
Why
by
can't
parts.
you?
Oh, thank you. Yeah.
That's it.
That's your life.
Add one. Because I enjoy the sleep. Don't sleep. No, keep sleeping. Keep sleeping. So like we'll fall. Keep sleeping. He goes like a random English accent. Like, no, it's just weird because we feel like talking like an American accent, and it's just like I'm just like talking in like totally Indian accent. It's like which accent?
It has to be in the interval for it to fail.
What three things do they have to be?
But there is.
Continuous decreasing time.
Oh,
We have to know one of our executions where one of our I have been stuck.
Oh, shoot, do we have to change those?
Okay, so it has to be positive.
What is the next positive out there? Is it just
No, wait.
The next one is infinity. It's infinity. It always goes up.
So it would be continuous. Like, I don't know.
You don't know anything about it?
So you can just think about it like true.
E to the 1 equals infinity.
True.
No, that's what a natural one is. Full Dunbar.
Full Dunbar,
Nice
2016.
job, hold on now.
Ryan.
2017.
Yeah.
Excellent.
Alright, that's enough.
You might.
Yeah, actually, like, I looked at it,
I got
the size of the English credit for
So diverges.
I could graduate this year.
Wait, what is that?
Like, the size of
I need my stats.
Yeah.
I didn't realize
the high school stands.
Actually, no, you can't because you keep on taking the derivative of whatever x.
So I'm taking that. I'm taking that.
We basically never get up to it.
So it's
Divergence like max is one over.
They just don't give up. Is it always decreasing?
I'm divergent.
Well, I'm not sure how I didn't get it.
exactly, wake the extras.
No, you can't. It's about time to wake them up. I see. So you're not limited to that. It takes the over and over.
Can't go with that logic.
Like the last one.
Because the
Section.
It's always.
Alright, so be there. The hop.
Is there an actual place called the hop?
Oh, the first one that early.
Oh, I've been to Hopkins Theater. No, we saw a movie there. We saw Home.
You could be
It was cute.
I like that.
It was a little kid movie about a like alien guy played by the guy from Big Bang Theory, who's played by Sheldon. Yeah. And this little girl, and they're in a flying car. And it's trying to, yeah.
Oh, I think
I like that.
Yeah, I did too. Yep.
I'm not kidding.
Where?
Or maybe I have to see the hop at
Do you think it was down?
So are you guys gonna
It's like, no, it's like the zip ties.
Oh, the zip ties, no.
Zip ties are way turned up. Yeah. No, if you want to. No, you get to like.
Yeah. That doesn't work in natural art as one of the things. Have to do educational. Alright, we're almost there. Give me 1 more minute, finish up.
I'm actually, wow. I don't know why. So basically, using stuff that would just in hard.
Oh, right, yeah. J.
Oh, is it literally? Wait, what time did you play?
J is Amanda Smith. 2016.
I'm guessing.
Oh, I forgot to do I just
The one that has a nice cap.
Okay, so any questions on number 1? So the function is positive, it's continuous, and it's decreasing. Hopefully you recognize that this was just a simple use of, and you end up with a natural log function. So you plug in, natural log of infinity is what? Infinity, right? So if you have infinity minus a natural log of 8, it's actually still infinity. Right? Yes. So if you have an integral that approaches infinity, that means that the integral diverges and therefore the series diverges. Okay, is that all right?
Yep.
Yeah.
Okay, so how did you have to do the second one?
Integration by parts.
Integration by parts, right? Whenever you have a natural log, that's always your u when you do integration by parts, right?
do L'Hopital?
It's not a limit, it's an integral. So you're not the first person, you're like the 10th person to ask me that. Everyone loves L'Hopital. We all love L'Hopital, but we're not finding the limit of this, we're finding the integral, which means we have to actually process the integral, so we have to do integration by parts. So, when you do your integration by parts, when all is said and done, and if you want me to write out the parts,
I got it.
right? You end up with, your u is ln x, so your du is 1 over x dx, your dv is, this was, careful with your ln x over x cubed, your dv is not x cubed, right? It's x to the negative third. So your du, d, so your v,
Oh, yeah. You're a legend. Way to go.
your v is negative 1/2 x to the negative 2nd.
So it's 0 plus.
So anyway, so when you're all done, you end up with, so you get uv minus the integral of v dq. You end up with this, plug in your v, plug in your 1. When you're evaluating, 1 over infinity is 0, right? Natural log infinity over 2 times infinity squared. How can we just look at that and know it's 0? What method?
Slow over fast. Slow over fast.
Yes, fantastic. Comparative growth rates, right? So you could L'Hopital, but it's comparative growth rates. So you get 0 minus 0 plus a fourth. So the integral converges to a fourth. Does that mean the series converges to a fourth?
No.
No, we don't know what the series converges to, but we know it converges,
So
right?
why?
Because we're just proving convergence,
Are there any problems?
not actually finding the sum.
Because we're curious.
Okay.
I just find this.
Okay, the last one. Anyone work the integral?
I did. Oh, I forgot to plug things in.
The fun part about this integral is this is one of those double integration by parts ones, right? Where you have to do it with 2 iterations to get everything on one side, right? Divide by 2.
How would you do it?
Except, do you have to?
Given the fact that you asked a question, I'm gonna go with that.
You are correct. Did we do our 3 checks? What's the first check?
Oh, it's always.
Is f always positive? No. So, no,
So this is all that word.
not positive. Integral test does not apply.
That's a lot of.
Okay, all right.
Shut up.
Okay, moving on to P series. A geometric series is number to the n. A P series is 1 over n to a number. So with a geometric series, your n is the exponent. With a P series, your n is the base. And I don't know for sure why they use P, but I think P for power, right? That's what I think. Because they're not going to use E for exponent, because then it'd be E, and we always think it'd be E that we know, right? So P for power. So anyway, the P series. Now, there's something real interesting that comes out of the P test. You're going to love the P test. Because with the P test, you can honestly just look at it and know if it converges or diverges, right? Yeah. All you have to know is if you have a sum of 1 over n to the P, if P is greater than 1, it converges. If P is less than or equal to 1, it diverges. The big consequence out of this, that's kind of a surprise to people, if you have the sum of 1 over n, that's the harmonic series. Based on the P test, does this converge or diverge? This diverges. So I still have people in every class who are looking at the original rule for the series and thinking, oh, it's always going down, it's going to converge. But that only works for sequences. It doesn't work for series. You have to do additional tests, right? So, yes?
So like if it was a negative P, then that like test wouldn't work.
The test wouldn't work.
Okay.
So, you know why? It was negative P at the end of the
Yeah. I see it, I see it.
Yeah. So, yeah. So anyway, so 1 over n diverges, but 1 over n squared converges. All right. You ready to try it? I have a few other things to warn you about that I told the other classes on the next page, but I'm going to tell you guys on this page. Couple other little tidbits. If I have some coefficient, if I have a coefficient for, and this is any function, it doesn't even have to be a P series, it could be geometric, it could be whatever. Right? Yes. Beautiful. If you guys remember Alright, so anyway, if you guys remember when we first started doing sums, which is back in chapter 4 when we were starting to learn Riemann sums, right? One of the things we learned is that if you have a coefficient, you can put it in front of the sum. So that being said, if you have a coefficient, does a coefficient have any effect on convergence or divergence?
No.
No, none at all. None at all. If it goes to infinity, 5 times infinity is not going to make a difference, right? And if it goes to a half, 5 times a half, it'll change the sum, but it doesn't change whether it converges or not, right? But, okay.
That would be 0.
Anyway, all right, so just know, if you have a coefficient, you may put it out front, and you're fine. So you can leave them in, right? I usually just leave them in. But if they bug you, right, you can take them out. Okay. Here's the other one that I want you guys to realize today. So, Shreyas, are you ready?
No, it's not gonna happen. This one
Chris
time.
can't take another L.
Oh!
Cancel out the
Okay.
You're gonna go back to 500 after.
Yeah, I quit. Oh, you can split it up into 2.
That didn't make sense.
Maybe he's a
I did.
I'm just making up new letters, right? So, that's
Wouldn't
N to the
that
P,
be
that's
brilliant
N to
if
the
you
Q.
just pick the different, like, the green, like, use one of those symbols?
Alright, so if you have a sum of sums or a sum of differences, right? You can split this into 2 separate segments. Yes, you did.
You gotta realize she's recording this, right?
One more time. This is
Another
Another one.
Okay.
Anyone
know.
He
That
just
was a
did it.
really good question,
Brian?
that was gonna be my next question. Alright, oops, that's a key. Alright, so, here's the thing. Say this converges and this converges. So if this converges and this converges, then the whole thing converges, right? If this is a half and this is a fourth, it converges to 3/4 and yay, okay? If this converges and this diverges, so they say this goes to 5 and this goes to infinity, what happens?
It's divergent.
The whole thing diverges, right? So if either one of them diverges, the whole thing diverges.
What if one both diverge, but one to infinity, the other to negative?
Doesn't matter what they're going to, if they diverge, they diverge. Oh, I see what you're saying, that's
So
cute.
it'd be like,
Yeah,
big
that,
Q?
yeah.
That was a valid
When we're determining divergence, we're not actually evaluating what some approaches, we're just using a test to determine divergence, and if it diverges, it diverges. It's a fair question if you get an infinity minus an infinity, but
Yes, then
All
you
right,
tell
I-
us
alright, I will check that. You're always trying to do those what ifs to me. Keeps me on my toes.
He's on video now.
Hey, Dylan, talk to me when you're
All right.
a three-hit wonder.
Alright, so no, that's okay, I need the what ifs, because it keeps me on my toes, right, I need that. So,
What if
I
it
want-
doesn't keep you on your toes?
okay.
She has to.
Anyway, why did I decide to record a commentary today? So here we go. I want you to take a minute, work with your partners, and figure out if each of these converge or diverge. You might have to write this in Sigma notation.
Two diverges. I can't talk to you because you're a three-hit wonder and I'm not. I'm not worthy.
I'm trying to teach you something.
Quiet.
So, anyone?
Quiet. Quiet. Quiet.
Have you got it?
It's 2/3, yeah.
Quiet. So hard.
I actually want to.
Sorry, you don't even know what happened back in.
Okay.
Theoretically, like, or relatively, that should be Earth is working fantastic.
I mean, you are, like, because every force has an equal opposite reaction.
Alright, so the first one. Does the 3 matter? No, 3 doesn't matter in terms of convergence or divergence. What is P? 5/3. 5/3 is greater than 1, so this series converges. Very good. Alright, for this one, so we have 1 over n to what power?
2/3.
The 2/3 power. Very good. Is 2/3 greater than or less than 1?
What?
So the series diverges. Very good.
It dies.
Alright. Okay,
I think 6 times.
so we have 5 quick series. And I want you to use any method in your arsenal. You've learned 5 tests so far, right? 5 tests, 5 series. Okay, so
Oh, is that trick style?
remember those 5 tests we've learned are the nth term test. You've learned the geometric series. You've learned telescoping series. You've learned the integral test. And you've learned the b-test, right? So, take a minute or 5 or 10 and see if you can get all 5 of these, right? All you're doing is determining convergence.
4-hit wonder.
Get out of here.
What a legend.
didn't even write down our C
If you guys are listening to Shreyas, he kind of helped you out with the first one with a nice shortcut to the answer, or to the end.
What was it? What did you say?
Shreyas, what did you say?
Arcseeker.
Oh, man.
What did you just say?
Are you talking about your mom? 5-1. At this point, I think they stopped calling her Wonder and just sort of like.
Now he's like,
Pretty much, dude. She's not even that
He slipped it in.
I'd say.
And then 2 weeks later he does.
Wait, do you want us to find the sum or?
Nope, just determine convergence.
Yeah, no, it's not.
There are two where you, no, there's just one where you can find the sum. Yeah. Actually, no, there's none. There's not even.
Oh.
Yeah, there's none.
Or not tell us.
What about virgins?
There's not.
Oh, about probably.
What did you do anyway?
Oh, you can put together the.
Yeah, so,
Yeah, so would that be
number 2,
1 over
diverges.
2 thirds?
What is number 1 diverge? I mean diverges.
Would that be 1 over n to the 2/3?
What?
Could you can you do that?
No.
Can you, cause 1 squared is, like 1 squared is the same as 1.
Can we do a-
Oh, they would have to be multiplying each other. I think I just lost all my stuff.
What is it?
I think he's negative now.
Yeah, I'm like,
What, I just gave you a hint about 3 minutes ago of what you can, which you actually helped us with for that series.
I know.
What did you do
Oh,
with that?
different.
Oh, I figured it out.
Yes,
I think I figured it out.
alright, very good.
Three diverges.
Yeah.
Oh, you put them into 2 different ones, yeah.
Wait,
Sorry.
diverges?
Nah, you can't do
There's
that.
R greater than 1.
Yeah,
And then R is less than 1.
And they both.
Especially since the way I got it was thinking of what it was that he said earlier.
Yeah,
I'm gaining.
Yeah,
I saved myself.
I love it, P-test, I love it.
Trace is number 1 on the chart.
Yeah.
Oh, is number 4 telescope?
P-test and geometric series are my, oh my god. So we'll make it easier.
I don't know why I can find the camera. Sorry, camera, they got to see me. No, I didn't. Sorry, guys. I'm sorry, camera. I failed you. I just dabbed in the background. I feel bad.
I have more than one time. Yes. Yes.
The website.
Yeah. Except there is a
Yeah, I'm just saying. It's equal. The only one I haven't done is one where we did keeping that close to the damage thing, like natural log, and I just like some token and cast. There aren't any X equals 0.
Thanks, calculus.
She was like, oh, dang.
You can. You gotta go watch the test.
What for 5 make that hit of 8 then? What's that? Because it's like as in a pick of it as it's not
I didn't get number 5.
Have you walked through all the tests? Do you have to do your medicine to apply?
You have the telescope. The end term is there's a limit if you want to try.
Oh, so I think first one earlier.